started. Hello, everybody. Welcome to the MIT Mobility Forum. This is session 167, where we'll talk about the technology on autonomous vehicle. It's really my pleasure to have two architects in this autonomous vehicle landscape join us today, Tony Han, the CEO and founder of WeRide, and Xiaodi Hou, the CEO and founder of Bot.Auto. As we know that AV finally reaching a stage beyond the pilot testing to really at scale operation. And I'd like to have Tony and Xiaodi really share with us the latest discussion, the state-of-the-art discussion on the technology foundation. Majority of today's session will be focused on technology. We'll try to cover four aspects. The first one is the role of simulator and today's world model and Gen AI. The second one is on the human in the loop versus strictly humanless operation. And the third one is this hybrid architecture between the end-to-end AI versus this deterministic safety layer. And then lastly, we talk about how to evaluate safety and provide support for legislation and policymaking. So those are the main topic for today. And toward the end, we may also ask Tony and Xiaodi to share a little bit on the business side and also their personal entrepreneurial journey. Before I introduce each of them to introduce themselves, I'll just say that both Tony and Xiaodi are not only entrepreneurs, but also hardcore technologists, right? So when I asked them, so what topic should we discuss? They both said, oh, let's talk about technology on this. So I'm glad. They also, WeRide and Bot.Auto are the rare companies who persisted and have survived without a major corporation backing them up, right? So I really applaud the effort and the endurance in this, not an easy industry, I have to say, over the years on this, right? So let's start with Tony, give a short introduction. Tony, please.
Hi, I'm Tony Han, the founder and CEO of WeRide.AI. WeRide is an autonomous driving company. Currently, we have operation in 40 cities, over 11 countries in this world.
Thanks, Tony. Xiaodi?
Hey, everyone. Good to see you here. My name is Xiaodi Hou. I'm the founder and CEO of Bot.Auto. We are a level 4 autonomous trucking company. Basically, we operate heavy-duty trucks, Class 8, and we offer the transportation as a service model. Instead of just building the technology, we also build the operation around it. And we're headquartered in Houston, Texas.
Great. Yeah. Thank you both for joining us. So let's start with the first question, which is the role of simulator and also today's world model. Let me pose a few questions together and then invite Tony and Xiaodi to respond. First one, what's the difference between this world model, today's latest technology versus the classic simulation, like more physics-based simulation on this, right? Particularly in terms of the sim to real fidelity discussion on this. What's the advantage of each of the two? Secondly, is despite this progress, there's always the debate on the world model or simulator versus the real world test on this, right? So we acknowledge that obviously, if you rely on just real world tests, that's an impossible job. The opportunity to get these edge cases is small, so therefore the learning is highly inefficient if you just rely on real world testing. Simulation provide all the possibilities, all the scenarios, but how do we convince people that simulation has enough fidelity to trust, right? So that's kind of a general set of questions. Let me invite Tony to start with the response, but also talk about the genesis, the latest model that WeRide developed.
Okay. Thank you for this several very inspiring questions. Actually, I'm more intrigued by your third question. That is, we all know the importance of simulator, right? But the third question is like, how do you just like convince people like your model is the fidelity of your model, like you are not simulating garbage, but simulating the real world. Actually, this one is actually I was inspired by kind of a conversation with one of my colleague in the bar. We just mentioned like, I say, how can you tell a simulator is a good simulator or not? He just told me two things. He said first, like, can your simulator do verification? That is, if your code is correct, and with our past experience, can we verify that your code is correct or is improved? Second is, can my simulator supervise me or inspire me to find some new edge cases, rare cases? If your simulator can become a prompt and can help you to find some rare cases, that really means your simulator can help. Like, just like the DeepMind CEO Hasbis just mentioned, like suppose like you stop all the data input in the year of 1911, if your AI agent can still find the theory of relativity, that means like you have a great agent of AI. And simulator, the same thing, if that one can help me to find something I don't know, I neglect, that is a great simulator. So with that said, I just want to share our new simulator to you guys. If I may, I'll just share a screen.
Sure.
And we are quite proud of this new progress. Let's see, let me play this video.
Autonomous driving is moving towards global commercial deployment and set to become the first large-scale application of physical AI. But long-tail scenarios are hard to capture. Road conditions, traffic behaviors, weather, and regulations vary widely across cities. Real-world testing is costly, slow, and risky. Building a simulation platform that fully models the real world has become key to industry progress. That's why the WeRide Genesis General Simulation Model was created. Powered by generative AI, WeRide Genesis bridges the simulated world and the real world. By combining high-fidelity physical simulation with human-like AI agent decision-making, it accurately recreates interactions between vehicles and complex environments. With 4 core AI modules that enable closed-loop training and optimization, WeRide Genesis significantly enhances the safety and reliability of autonomous driving systems. It is applicable across all scenarios, building urban environments in minutes with high fidelity, condensing millions of kilometers of testing into a few days, seamlessly turning digital AI into physical AI, and bringing AI drivers from the virtual world into reality. WeRide Genesis can simulate any road condition, such as unprotected turns, night scenarios, rush hour traffic, and various other road conditions. WeRide Genesis can also create fully customizable scenarios, such as removing road users, introducing new behaviors to road users, and simulating vehicle lane changes and other maneuvers. It can simulate different sensor viewpoints, is adaptable across L2++ to L4 sensor setups, adaptable across multiple AVs, capable of generating large-scale urban areas, and can simulate billions of kilometers of real-world driving to train AVs at scale. WeRide Genesis is built for mass production, using one engine to power full scenario simulation from level 2 to level 4. Generated once, usable worldwide.
So that is our a short introduction of our Genesis. The most of video you see actually, especially at the beginning, that commercial thing like, WeRide has operation. All the rest of video are all simulator generated. So it's kind of so realistic, and we use this kind of simulator extensively, and most recently in 2 autonomous driving competition in China nationwide. We won the championship twice within like 3 months, and we beat Huawei, Momenta, Horizon, all the ADAS company you know in China. So I think that one is quite powerful, and I'm quite excited with our recent progress.
Great. Thanks, Tony. Xiaodi, what's your view on this? I mean,
Okay,
you guys have the foundational model to all architecture. Yeah, tell us more about it. Yeah.
Sure. Yeah, I mean, I was like really looking carefully about what Tony has presented, just making sure that we don't have any conflict. And in fact, there is none. There's none. And I'm glad that, I mean, Tony and I were good friends, and I think there's one of the reasons is that we're all very allergic to bullshit. So let me tell you something about simulation. I think there's a world of PR or marketing, and there's a world of reality. Let's split. on one hand, the simulation, people talk about we can synthesize like a rain scenario, snow scenario, whatever, but only in cameras. On the other hand, most of the autonomous-driven companies, especially for level 4, are multi-sensored. I give you one like my personal experience, which unfortunately I don't really have the video footage. I wasn't really sure about the format of this forum until this morning. Jinhua told me maybe you can show some video. I wish I could show you the video, but I can describe the video to you. Like one day we were in a situation driving in the southern part of the US from Houston to San Antonio, and all of a sudden, like without any visible information, like the LiDAR signal just degraded dramatically. And then later on, we just reviewed a lot of the data on that area, because if you have the moisture level of the scene of your road condition to a certain level, the LiDAR signal seems to be like blocked by this mist or fog. But in fact, it's actually not from the visible light. I mean, from the visible light, everything looks normal, but your LiDAR signal just like a condensed around the vehicle, just like as if you were having the invisible wall around you. And this was a very shocking scenario that I have never seen before. Maybe blessed by the southern Texas weather. This is something really interesting and new, and it actually inspires a discussion internally about, okay, what kind of sensor simulation can we do? And can we ever simulate something that we have never seen? And the answer is no. We will only simulate things that is very well understood if we're talking about the sensor simulation, because it's a synthetic process. And you really can't synthesize the process. I mean, of course, you can synthesize everything, but most of the thing doesn't really make sense because it has to be drawn from a distribution that you know about, right? So I think for sensor simulation, the current status of the world, or the current state, is that everyone tries to work on some sensor simulation and try to give you the visually appealing results. First of all, it's camera only. And the second is that like the human naked eye, I mean, it's relatively easy to fool the human naked eye, but it's relatively hard to really make this data meaningful for the validation process for computer algorithms. And also, how about LiDAR? I mean, I don't really feel that people can reliably simulate all of the LiDAR point cloud generation physical process appropriately. So that's a problem for simulation. And if you're really thinking about investing more into the more photorealistic or eye candy type of simulation, it's basically you're investing in hi-fi. If you buy a $100 earphone, you get some sound quality of that $100. But how about $1,000? How about $10,000? I mean, your investment in sensor simulation is almost indefinite. But on the other hand, the return of that diminishes very quickly. Like, I think, I mean, I'm stopping investing in hi-fi headphones until like $1,000. But some people can do more crazy than me. But I mean, I don't really feel that the return is diminishing. So that's for the sensor simulation. But I think sensor simulation is one part of it. What I think Tony has shown, which I really like, is probably on the other half. That is the behavioral simulation. Because behavioral simulation, very unlike to sensor simulation, doesn't really require you to understand or modeling the real world human behaviors. Because after all, we're not dealing with the human habit. We are dealing with the physical limit on how crazy a driver could become in the roadway interaction. And that is the part where the real world data is become less relevant. And this is the opportunity, for example, as Tony also has said, how can we be more innovative than the data? Or how can we transcend from a data-driven approach to a more advanced approach? I mean, internally, we call it a transformation of the paradigm from data-driven to computing-driven. And this paradigm, we don't care if this like we call it NPCs, actually other agents, like other agents' behavior is really looks like a human, or is that coming from the norm of a human driving experience? All that we care is that is that physical defying? If it's not, then it's a good NPC driver. And if it's an NPC driver and it's collide with our truck, okay, whose fault is this? right? We wanted to understand the liability of the level 4 autonomous driving. And I think that is where the simulation can really taking a step up from, say, AlphaGo to AlphaZero.
Yeah, so maybe a couple of things. One is there are always some abstraction of the reality here, right? The perfect replication of the reality is not useful and also not achievable in many ways. One thing I do want to ask both of you is the two different pathways, right? For example, last fall, we interviewed Drago Agdalorov from Waymo, talk about how Waymo adopted Gemini, has this kind of a gigantic world model into the AV driving situation, versus WeRide and Bot.Auto both developing this AV specific world model there, right? Do you see any advantage or disadvantage of either approach? That's also remind me, so you wrote an article on scrappiness beats scale, right? That triggered me the link on this. And any comments about this different possibility there?
Yeah, or maybe I can just start with this question. I really feel that the world model, everyone is trying to use world model. I mean, why the world model is giving us the so-called the new hope of the AI age is really because I think world model basically is telling you to predict the world better so that you don't need to go into the real world feedback loop, but there is a more synthetic, more economically possible and more efficient synthetic feedback loop that you can do. But really for the world model, when we do autonomous driving, it's really about how the others are interacting with you. Sure, you can use like a pixel level simulation. I mean, that gives you more fidelity. But again, on the sensory level, I don't really believe that fidelity brings any value into the system, or bring very minimal value, just like hi-fi system, into the system. And of course, I mean, Jensen would like you to simulate an atomic level. I mean, that will be really helpful to sell more NVIDIA cars, right? But I mean, who has that capacity? Who has that capability? And what is the return of if you're doing the atomic level simulation? And what if you have a lot of knowledge about the legal, medical knowledge or English literature knowledge? And does that ever help when generating another behavior of another agent? It doesn't. So I mean, world model, I mean, the bigger the world model is, the better your marketing would be. But I don't see the value of it. So this is, again, my scrappiness claim. I mean, you only pay for what is very valuable for you. You don't pay for those high ROI stuff. So I really don't think there's anything that we wanted to even invest into that.
Yeah, again, this is appropriate level of abstraction here. That's relevant here. Yeah, Tony, what was your thought on this? You're on mute.
I think I fully agree with Xiaodi. You know, why don't we have 8 eyes, right? You know, it would be good if I have 2 eyes looking my 6-point direction. You know, in the mid age, I can prevent somebody from attacking me from my back, because you know there's too much cost. You know, the eyes are very expensive. So you know, the bill, you know, as a startup, you know, we spend, like, as you mentioned, we don't have a big giant behind us. Like Waymo has a Google seat behind Waymo and has an open book mode. So we actually paid like super high bills for the simulator and cloud computing. So we only want to simulate to the necessary level. We don't want to waste for the bill. Besides, you know, think about it, I think it's a huge waste of energy. So
yeah,
we shouldn't simulate what things are irrelevant. Okay.
Indeed. Yeah, good. Thanks. Yeah, let's move to the second category of questions, which is the human.
Jinghua, sorry, I just wanted to be sure about the format. I see a lot of chats popping up. But,
don't worry about it.
Okay,
do not worry about it. Yeah.
Okay.
Worry. Yeah. Cool. So the second question is on human in the loop versus strictly humanless operation. On that, probably there will be differences in terms of passenger vehicle versus the trucking. Also, potential between in the urban context versus highway context. There, yeah. So first of all, to say human in the loop somehow just sounds nice, right? People always have this idea of let's have a human machine partner with each other, in many occasions for good reasons.
The Skynet is under control.
Right. Yeah. But Xiaodi, you reject that notion, at least in the particular context. You argue the humanless is actually better. For that, Tony and Xiaodi, I want to hear from both of you. Maybe Xiaodi will start.
Okay, so yeah, I got a little video about it. So
sure.
let's start. Hopefully it's not too promotional. This is the video about our very first full driver out validation for Bot.Auto. We actually have remove every human from the truck. There's no human from the front seat or back seat, and the vehicle is all driving by itself. So this is our little video. Maybe you can start with a video, and I can explain a little bit more about it. We're starting from a very commercial hub called Riggy's in Texas. Coming back to another public transportation yard, and no human here. And in the end, actually, the door opening was actually done by the people inside the hub. All right, so I'll stop sharing here. And the point I wanted to make is that the reason why we're emphasizing a lot about there's no human in the vehicle, there's no way that we're controlling the vehicle remotely, is because this is a reality. The reality for truck driving is that for a significant portion of the mileage, we're not driving in a densely populated area. We're driving in sometimes like a very remote area where there's no cellular signal. And when in a kind of a stormy day, if thinking about satellite, there's no satellite. Even in the mountainous area, there's no satellite. So all of these things are actually challenging the premise where can we find the ultimate safety net of a human interfacing, controlling the vehicle? And in fact, we just can't have that. And I think this topic has been getting more and more surfaced when we see no human in the cabin. Like for example, Waymo recently had disclosed the number, actually the ratio of the remote operator in Philippines versus their number of vehicles, which I think is a good ratio out there.
Which is what's the ratio?
I can't remember exactly, but it's like a 2-digit number for human controlling the 4-digit number vehicle.
Okay.
Tony, if you have that number, I can't remember exactly.
I don't recall. I don't recall their exact number. Yeah.
Yeah, but I think that's a kind of a good number. But I think when it comes to the like a true humanless versus human in the loop, we have to answer parse the question from the two dimensions. One is the latency, and one is the bandwidth. How much latency are we talking about, and how much bandwidth are we talking about? I mean, if I wanted to further complicate this question, and what is the availability? What is like a P90, P99 availability of this requirement that we're talking about? So I would say that the operating domain for trucks and cars are very different. The availability is just not there for trucks. So that's why it's important we have seen thousands of autonomous cars operated without a human in the cabin. But let me just do a tally. There are only 15 autonomous driving trucks and 15 trips that happened without a human driver. And 10 of them were delivered in TuSimple back in 2021 and 2022. 3 of them are delivered by Aurora, and 2 of them are delivered by Bot.Auto. And maybe the question is like, why this is so difficult? So this is a point where I wanted to make that if you have someone who has the ability to control the vehicle versus you are suffering from the low bandwidth, high latency, low availability, interface for controlling the vehicle, you really have to think things differently. And this is why there's only a very few driver out runs in there. And in addition to that, I heard some rumor says that either all of the trips or some of the trips by Aurora, they have the so-called observer in the backseat. Of course, you can say that observer doesn't really do anything. But if you have someone in the vehicle, I consider that as cheating, because if you have someone in the vehicle, you have the infinitely high bandwidth in observing the scene, and you have infinitesimally low latency in controlling the vehicle, even if it's like a one big red button to press. So these are my considerations. Like, we need to understand how much human is involved in there, and really like how humanless it is, because in the end, it really matters. One is the availability of your service in different areas. On the other hand, is like your operating cost. Okay, I'll stop here.
Good. Thanks, Eddie. Tony.
Well, I think, yeah, I just want to echo Xiaodi's comments. I think, to make the driver out for autonomous driving is extremely difficult. There are so many autonomous driving companies, but if you look at really driverless operation, only very few companies can do, like Waymo and WeRide. There are some companies that just mention like we can do robo taxi, but mainly you have an ADAS system and with a safety officer sitting in the car, as Xiaodi mentioned, with an infinite amount of bandwidth, and showcase some demo. But remove human means like you need to have very high level of reliability, have some mechanism of redundancy to handle all of this. So that's the key problem.
In WeRide, do you guys have still remote assist there for many of the passenger operation?
Yeah, we still have basically our approach is quite similar to Waymo's approach. We still have remote assistance, but they are only there to give certain suggestions, instructions. We call the remote hint or remote suggestions, but they don't control the car, because the latency will just kill you. So basically, if you want to remotely control the car, it's just like you are driving autonomous driving vehicles in Mars, right? Do you see the one of driving Mars, the vehicle just move like as 1 meter every 5 seconds because the latency. So that's our current approach.
That's right. I think that's where the remote operator is a bad word to describe it. I try to use remote assistant. You guys probably come up with a better name to clarify the confusion here. That's right. Good. Yeah, thanks. Let's move to the third question, which is this hybrid architecture. I think starting from last year, almost all AV companies said the following. They say from one side, we have the end-to-end AI models that can help deal with edge cases, introducing common sense reasoning. At the same time, for the safety guarantee, we have the deterministic safety layer, and the two work together. That's right. So I want to sharpen the discussion a little bit. The first one is, what's the arbitration logic? Say if the end-to-end AI model versus deterministic safety layer contradict each other, what's the hierarchical logic to trigger which one being the final decision making on this, right? The second one, maybe I'll finish all the questions here. So the second one is, how are the deterministic hook injected into the runtime to ensure that the generative one does not bypass the basic physical constraint or safety requirement of this?
So I think that's a very good question. So basically, we want the deterministic scheme. We call it like our safety net. That kind of model to be silent 99.99% of the time. So this guy just as a guardian and don't speak at all most of the time. Only if that system is so sure that the vehicle is going to collide with something within like maybe 500 milliseconds or within 1 second, it's so sure, and it start to activate and do something to override the end-to-end system. That's current mechanism, because if you want to build up a charge between the deterministic system and end-to-end system, what if the charge itself make mistakes? The likelihood of the charge making mistakes is very high. So basically, our mechanism is like get a very silent deterministic system that, try to prevent collision. That's the approach. But ideally, we still want to build something. You can never prove mathematically that your end-to-end system is safer than a human being because you simply lack of model of human being driver behavior and end-to-end system. I think all of this are probabilistic. So if by statistics, or like one day our end-to-end system is safer than a human being, we can just rely on the end-to-end system. So far from our statistics, we still have lots of work to do. But with our current hybrid system, we can already are capable of real operation. Today, if you there's only one place you can hail driverless robotaxi outside of US and China. That's in Abu Dhabi, and you can hail or WeRide robotaxis through Uber. That's the only place you can do driverless robotaxi. But in China and US, you can find in many cities. So that's our approach.
Thanks, Tony. Xiaodi?
Okay, I think there are two types of questions that we wanted to solve for autonomous driving in general. One is the safety problem, and the other is efficiency problem. And I think every efficiency problem should be bounded by the safety boundary. And within that boundary, yeah, you can use whatever method, no problem. We would love to have end-to-end methods in solving this efficiency problem. But at the outer layer of the efficiency, so-called solution space, we need to consider that there is a safety boundary. And this safety boundary, in my opinion, is more about liability rather than that accident itself. Because especially based on my background of doing autonomous trucking, I always halfly joked about this, trucks can't dodge bullets. If someone is decided to hit on our truck, there's no way that we can get rid of it. It just happens all the time. Because the velocity or deceleration of a truck just is not there to avoid every single accident. So what we have to be considering more is about the liability framework, basically whether this vehicle is liable or not. And I think because of the physical constraints of a truck, it just can't be having an accident-free operation, say in New York City. And that is why in certain areas of the New York City, it doesn't even allow trucks to be operating on the Class A trucks. And I would say that this is maybe the foundation for me to think about how the end-to-end AI model is coupling with the deterministic safety layer. The safety layer or the liability layer has to be more deterministic, because most of the time when in the operating domain of a truck, even for human society, there's a very well-developed liability assessment pathway. Just like a highway patrol can say, okay, so you're at fault, you're not at fault. This is a very simple assessment there. And that creates the deterministic basis for our system. And on top of that, if there's an efficiency improver, certainly whatever way that you like, end-to-end is the way to go, maybe.
Good, thank you. That actually connects well to the fourth question on how do we evaluate safety here, right? Let me be more specific on the question is, when is evidence sufficient here, right? And also maybe I context with one often very difficult discussion, that is, we have this idea that safety is sacrosanct. We cannot trade off safety with cost, right? But in reality, that's not true, right? Again, it's a difficult discussion here, right? In reality, that's not true. In US, we kill 42,000 people every year. So de facto, US society choose a balanced point, that is, we're willing to sacrifice 40,000 people in order for the society to operate. I'm not necessarily agree with that position, but that's de facto the position here, right? My question to you guys is, under what occasion we can demonstrate there is sufficient evidence to show this is good enough on this? And how do we both objectively measure this, but also inform the public and the decision maker about this?
So I think, first of all, I would say one thing I will always ask, suppose I give you unlimited amount of budget, how safe can you make your autonomous driving vehicle be? Okay, so I think you can maybe make it 25% or 30% or at most 50% safer than what you have with a limited budget. And then you think about it like, how do you fill the gap? So without increase your cost too much. So I think the main barrier currently is still like we want to really find better method or better mechanism to improve the reliability and the redundancy of the system. And in terms of how can we convince like the public that autonomous driving vehicle is really safe, and how can we really prove it? I think we have two approach. One approach is like through statistics. Like, I think the car insurance company these days, like, by the way, in China, we have a lower premium for our autonomous driving vehicle than human drive human drive taxi in China, just because the car insurance company do the math and they can cover our operational vehicle with less premium, with cheaper premium. So that already tells you like statistically what we can do. Secondly, I think we can do some scenarios like at the beginning of this, when we prepare for this lecture, and you said your Tesla run red light, right? That scenario, you have to really prove like by statistics, like your autonomous driving vehicle shouldn't run red light, and that one can be done mathematically or probabilistically. So for that scenarios, like you cars can avoid holes on the road, this kind of scenario, common scenario, you should make sure autonomous driving vehicle can handle them. I think that's the two main approaches we tackle this problem.
Yeah, I would add something here. I think statistical numbers are important, but since we're already talking about regulators, I really wish that we could have a so-called the driver's license test for autonomous vehicles. Because again, there are a lot of things. I mean, Jinghua, you mentioned about what is safety? Is safety a so-called sacred term that cannot be compromised at all? I mean, I was smiling because I've seen so many scenarios where we are literally getting into like a trolley problem. Like there are non-compliant drivers here, and there are specific areas where the liability is not 100%. And in those areas, how are we going to behave is really because I mean we have to go back and check into the like a court records, for example, or where the traffic accident and highway patrol reports, in order to just as if we're thinking about this, like there's a legal system and you're entering the case. The judge is actually, by making their ruling, they are refining the definition of the law, and they're basically that's why there's a case law. And there's just like so many of this case law giving the more and more refined boundaries of who is liable and who is not. And we're getting into that area where the top-down approach of instructing you're liable, you're not, is becoming at the edge of it. Like it's on the border of not being useful anymore. And then now I think as we're approaching to this more like a case law system, the cognitive difference between the human driver and the computer driver starts to show a lot of difference. For example, the human driver, I mean, I've passed my driver test in one run, which I'm fortunate, but many of my friends who didn't really pass their test drive in one run, and we're joking to each other, don't worry, this human test drives test runs are actually designed for human capacity, that you are almost guaranteed to pass it if you want, you really have to. And but for autonomous driving, we don't really have that guarantee, and we don't want to make sure every autonomous driving vehicle after long enough trials will pass it. Therefore, I think it would be better if we can throw in thousands or even tens of thousands of real like case law scenarios into the system, making sure that they must pass all of these tests before they can get in onto the road. That will be a very helpful thing for thinking about the liability determination from the regulator's perspective. Just giving them a driver test, no matter how hard it is, I'm sure the best autonomous driving company will never complain about the test. They will pass all of the tests.
Good, thank you. So a bunch of questions. So let's do a quick round here, right? So from a technology point of view, what are still unsolved from your point of view?
I think there are still many problems in simulators that are unsolved. Like, think about, especially like one thing I think, uh, is that possible, like the simulator, give you infinite amount of computational resource. Can you find like all the rare cases like may appear in this world like in the next 100 years? So I think, these are problem unsolved. I would pay whatever money I have for such a solution. So, if we can simulate, there's a lot of things. There is a big difference I want to emphasize between digital AI and the physical AI. I always mention to my colleagues, I said, hallucination in digital AI may be entertaining, but it is fatal in physical AI. So, if we can try to avoid this kind of fatal hallucination, this kind of fatal accidents through simulator, that would be great. And we put lots of resource in this kind of problem.
Thanks.
Yeah, and Jinghua, when you were asking this question, I give myself a pause. Like, is there a really unsolved problem? I mean, I can't think of any. But on the other hand, I think what keeps us busy every day is really like all of this. I would say most of our current work are about internal efficiency improver, either to improve our own velocity of development, like reducing the cycle. For example, as Tony said on simulation, there's a lot of things that we're still investing on as of today, working on really hard to improve the simulation so that improves the overall development efficiency. That is one. And the second is that we're also improving the efficiency of our operation, like our data pipeline efficiency and our operation like deployment efficiency, all of this. So I think for efficiency improvement, it basically is an endless pursuit. But on the other hand, and if you ask any company who has completed their so-called their safety case, I don't really think that they will admit anything that they haven't done, because by definition you finish your safety case, you put your vehicle on the road like reliably, you should be confident about your system. You don't have anything on the to-do list that you have to do but you have not done yet. So I think that's probably the status for many of the companies who are in operation mode, like Tony's company, my company, is in this stage.
Well, one question specific to Boston, right? We have a lot of snows, right? When do you guys feel comfortable having a passenger robotaxi operating in Boston in the winter snow time?
It's for trucks. I mean, it's less of a problem. I think people are really disproportionately overemphasizing the challenge of the snow. I think it's not that of a problem, especially if you have a sensor cleaning system, which we have, and like a sensor basically warming up things. I mean, the only operational challenge is that sometimes it requires, like a dark ice requires the chain on the tire to be making sure that it's driving safely. For that part, different trucking companies, like human trucking companies today, has different treatments to that. Some companies just will basically stop operating. I mean, currently we admit that we don't have a humanoid robotics to install the chains on the tires, but I think that is really a minor problem. And if you look at the fraction of the days of operation that be interrupted by this, very small. Tony.
I think the reason that you don't experience robotaxi in Boston is mainly a policy issue. It's not a technical issue. Yeah. So if we write this loud, I'm pretty sure we can start an operation within a quarter in Boston. But sadly, we are not allowed to do operation in Boston. And Waymo, I think Waymo still, Waymo still needs some time to finish the operation, to fulfill the duty of the operation in New York and then come to Boston. But I think it's mainly a policy issue.
Yeah, good. Thanks. I think that's all the technical question, right? Maybe 2 or 3 minutes talk a little bit on the business side, on the entrepreneur side. On the business side, Xiaodi, you quite often emphasize this operation cost per mile on this as the real metric to check, right? To whatever degree you can share, right? Give a sense of what's the cost per mile operation by human-driven trucks, and where you are as the autonomous trucking company today, and where you think you will be in, say, 3 years' time? Well, what's the cost curve projection? Yes.
Yeah, human driver there's a national research on it. So I'll just quote the number from American Trucking Research Institute. The last year's number is $2.26 per mile. Basically $1, about $1 you paid for the driver, and for the $1.26 you paid for everything else, including fuels, insurance, truck depreciation, and everything. So basically $1 human related, $1.26 truck related. And I think this number translates very well to our system. Right now, we pay our driver much higher because their safety drivers and their safety trainings are important, and they're part of their paid time. So we actually pay our driver about $1.80 per mile test driver. So these are the R&D test driver. But apart from that, as of several months ago, I mean, I don't have the newest number, our autonomy related cost is 64 cents per mile. That is already much lower than that of a human, and the truck related cost is the same. And I wanted to also emphasize one point here is there's no commonly agreed methods in calculating how this number has been aggregated. And of course, you can write off these things this LiDAR is for R&D purposes, so don't include that. And that is that software update glitch is an R&D problem, so we don't include in that. But for us, we take a very hardcore approach. Every dollar spent on the accumulation of the miles, if something that is related to the accumulation of the miles, it has to be included. So thinking about this, if give you one example, if we're training the system that doesn't really have any, we're training a new deep learning model, I would not consider that as a cost, because the deep learning model is independent of the number of the miles that we accumulate. But if you're thinking about renting a parking spot in a yard, that has to be considered. And if thinking about if you're buying a ladder so that you can climb on the ladder to clean the sensors for the trucks, that is also operation related. That has to be included. Thinking about if you're operating today versus you're operating in 3 years with 100 vehicles, if any variable of this operation will change your investment amount, that number has to be included. So by including everything all together, we know that 64 cents is a very honest answer that I can give out to the world as of today. And this number, of course, will probably be halved, hopefully next year. This is we're going to see this number dropping every year, and my hope for the entire fleet, entire company, including the R&D drivers included, we wanted to make sure that the number is below $3 by the end of this year.
I see. Tony, on that, maybe a narrow question is also whatever you can share about the costs, etc., particularly recognizing the labor costs in China is much, much lower than the US one, right? But let me ask you a broader question. Give us a sense of the scale here, right? Total number of vehicle operating in the world on the way, right? And also, do you see the next few years the growth in a linear growth way, or you are going to say 5 times it, 10 times? What's the ambition in 3 years, let's say?
I think a great question. Actually, I did some statistics about our development. So currently we are operating at the thousands level, right? We the goal is by the end of this year, we probably have more than 1,000 robotaxi, driverless robotaxi operated in China, and close to 1,000. We strive to make close to 1,000 robotaxi available in the Middle East area. That is UAE and Saudi. Of course, depending on the policy progress. In the year of 2026, we are at the thousands level. I still remember in the year of 2023, we are at the 100 level. And in the year of 2020, we just achieved the driver out for robotaxi, because driver out in robotaxi is, I think, from my view, my personal view, is much easier job than what Xiaodi has done for driverless truck. 2020, we achieved driverless operation in robotaxi. We have a fleet of 10 or 20. So if you look at numbers, so it's exponential. Every 3 years, we come to the next magnitude. So I would say in the 2028 or 29, we are at tens of thousands level, and 2032, we are at hundreds of thousands level. And then exciting things, but according to the BCG report, 2034, 2035, a company like WeRide, we have like 1/6 or 1/7 share of the whole total robotaxi deployed. That is like a 1 million level. Remember, in China, every year, 30 million cars are sold. So, that's the trajectory we expect to achieve.
Great. Thank you so much. I'll give the floor to John for questions.
Okay. Tony, Xiaodi, we had a super active chat, and we will share the chat file with you because there are lots of great questions and comments in there. Before we get to the specifics, let me just start with a general question about the kind of the interface between the machine and its environment. So there was a cluster of questions starting with Mark Helmbrecht. Do these autonomous vehicles ever honk to warn others who seem to be doing something unusual? Elena Renda asked a similar question and added.
So my question, sorry but just simple question. Yes, in China, our robobus and robotaxi do honk to give an alert. Yes.
And Xiaodi, I'm assuming it's the same for the trucks?
Not yet, because right now we don't really see any scenarios where honk makes sense so far yet. So, I mean, I think for truck driving, this situation is a little bit different. But
okay.
Not yet.
Okay, so super quick follow-up from Elena. Are these trucks advertised to be driverless? So are folks aware generally that these trucks are without a driver?
For us, yes, there's a little blue dot, and we actually submitted our proposal to the Texas DOT to basically encourage others to know that if there's a blue dot is on, it's driving autonomously.
Okay, excellent. Similar question from Bernard Farrell. He writes, as a driver, cyclist, and pedestrian, I use eye contact to ensure that I am seen by the human driver of the vehicle. What indication from the autonomous vehicle can be given to me that I am seen? Do you think this is necessary? This is a long time debate within the industry. Where are we today in that sort of machine to human, machine to environment interface?
I would say, so first of all, I don't think the cyclists, or we call the VRU, or the pedestrians, need to see from eye contact or have certain information to get from the autonomous driving vehicle to reflect that I see you, because that information, that kind of communication is very noisy and can be misunderstanding, because I say I see you, but what is you? You think you is you, but there's another guy in your blind spot. So that is very confusing. So I would say just make a robotaxi or autonomous driving vehicle that can see everything like in the surroundings. Adding some sensors, I think that's the right way to tackle this problem.
Yeah, I would say I totally agree with Tony. I think this is more like a good to have, but rather than must have thing, because all of these eye communications, they make a lot of mistakes. Like if people are like winking at me, either they're like saying like your car has a cool color. I'm driving a yellow car, so yeah, sometimes I got people like waving at me for this. But sometimes like people are just like, hey, why are you stopping here? Or why are you driving so fast or so slow? I mean, I don't really understand what they're saying. That's a problem. Like if you have a misunderstanding of this interaction, you have a problem. So I would say this is like a much later in the stage. It's like a low priority, good to have feature in the back burner. I'll say, not really something that we really need to solve for now.
Okay, there's a cluster of questions around simulation. Before we get to those, if I may just add a clarifying question. So I think we understand that simulation is used to simulate the operational design domain. Is somebody wearing a T-Rex outfit walking down the street? Is there snow on the Golden Gate Bridge? Things like that. Is simulation also used to simulate the physics of the vehicle? And a specific example that was mentioned by Sal Tannenbaum is black ice, right? So is it used to sort of simulate how the vehicle actually reacts in sort of icy conditions and so forth?
Yes.
To us, we have different levels. Like, so first of all, this simulate at the physical level is very, very expensive. So we do something like slippery but we don't simulate a collision, because for autonomous driving, our goal is try try to not collide, right? So we don't simulate collision like that car is kind of soft, so we can bump into that car. That kind of level we don't go. So again, simulation is very, very expensive. You treat it as an electricity or US dollar. You try to save every penny for more valuable research, right? I was a professor, so I try to save every penny for more valuable research. So simulation is like that thing. So I only simulate whenever it is necessary.
I would say that, agree with Tony. We can only selectively do the very complex dynamic simulation for control. But I think the good part is that where you need the breadth of simulation is where all of the scenarios, like interactions are happening. But for this type of a control-related simulation, the domain is relatively small. So like only a small number of things need to be simulated, relatively small. I'm not talking about tens of thousands of different control scenarios. But yes, I think they have to be treated in different level, and cost matters.
Okay, there's a whole amazing cluster of questions around simulation. We're at time. I just want to quickly ask, so Jay Modi asked a question, what exactly are these humans controlling? So this is in the conversation around human in the loop. And I think this deserves just a little bit more airtime for people who might not understand, particularly with this controversy that we've seen with Waymo vehicles being controlled by people in the Philippines and so forth. Could you just help our audience to understand a little bit more? Who are these people? What are they actually doing?
So, for example, suppose there is a road construction, and there is a sign like people dressed like a constructor and taking a sign like take a detour, and however the sign is almost close to readable and very, very, very scratchy. And then there's some confusion inside the car whether I follow his suggestion or not. And then, that car will just pop a message to the remote operator to see, should I follow this sign? You just say, okay, follow this sign and then do the detour, that kind of information. But exactly how to make a left turn and do the detours, that is the job of the autonomous driving vehicle. So basically, operators are kind of responsible for very high level vague information that human communicate with human, that kind of thing, remote operator need to do, which is usually very, very rare in a day-to-day routinary operation.
Xiaodi?
Yeah, I would say just again, thinking from the latency perspective and bandwidth perspective, all that you can do is really like high latency, assuming that every signal that you get from the vehicle is like at least give you at least 5-second latency, at least. And the bandwidth is sometimes can also get very low because you're not transmitting a large number of signals. If it's high latency, high bandwidth in control doesn't really make sense at all. So high latency, low bandwidth. Okay, figure out what you can do. Basically, it's about like high level instructions. You can't really tell them how to drive, especially for like a truck driving on highway. And there's no way you can do that. But yeah, how you can maneuver the vehicle? Is this like crash scene clear so that you can continue, or are they waving hand for you to do some asking you to either making a lane change or something, and then you go follow a route? That is really like for example human level interaction, and even sometimes like a policeman will say something to you, but you never wanted to like using an AI system just to learn what they have yelling at you, and then you're going their way. That's no go for that type of like a high noise level interaction. You have to verify that with a human because there's a liability behind that.
Thank you so much. I'll turn it back to you, Jim. Just a quick note that Alan Kornhauser had a lot of really interesting comments as well. Maybe we can bring him and his team at Princeton into the post-meeting debrief.
Indeed, yeah. Thank you, Alan, for joining us. So many interesting questions there. I have still 2 more pages question to be asked on this, but given the time, everybody please join me. Thank Tony and Xiaodi for the conversation today. It's really great for you to share with us on this. Right? Yeah.
Thank you.
So for Tony and Xiaodi, if you don't mind, we have a debriefing in the breakout room. We'll do that in a few minutes on this. For the audience, just a quick announcement for next week. We'll have Professor Dan Hess talk about Don Shoup. He wrote a book on Shoup's legacy in the parking and going beyond the planning but influencing the whole society. We have a tribute session about Professor Shoup next Friday. So have a good weekend. I'll see you next Friday. Bye-bye.